Yeah, let's check out question number 3. In here we have a rectangle ABCD, which has a width of 10 centimeter. That means this side is also 10 centimeter, and the length is 15 centimeter. That means BC is also 15 centimeter. Inside we have 4 small triangles, I think, and then this angle is 35 degree, and this angle is an obtuse angle. That means it's greater than 90 but less than 180. Okay. Find the area of the triangle BCE. Okay, before we get started with the solution, one thing we have to understand is we know so far we know two equations for finding area of triangle. One is half into base into height, or half into b into h, half bh. Another one is half into ab sine c, where if this is a, this is b, this is c, then this angle is a, this angle is b, this angle is c. So we will take any two sides. So we took a and b, and then the sine of angle between these two sides, that's the angle. Okay, so if we will do it both ways. So uh, first we'll do this one, where this is the base. Okay, now we just need to find the height. Okay, so instead of finding the height of this triangle, since we don't have any other information but this one side, we will go and find the height of this side, which is this portion right here. Sorry, this portion right here. Okay, and then we will subtract that height from 10 to get this yellow height. So let's get started. Okay, first, since this is a rectangle, that means this is 90 degree. 90 minus 35, this is 55. Okay, now we can use sine rule to find angle E. Okay, why do we need the E? Our goal is to find this h. In order to find that h, we will use this right angle triangle. In here we have the angle, we need another side. It could be this side or this side. Okay, so but we are gonna go with this side. So in order to find this side, we could use cosine rule. Cosine rule, where we have this side, and this side, and we have one angle. So we will have an equation with only one variable, which is this side, AE. Another way is we could use a sine rule, where we are gonna use this angle and the opposite side, similarly this side, and then the sorry this side, and then the opposite angle. In order to find this angle, we need angle E. That's why we are going to find E. But if we use cosine rule, we won't need that. So I think we can go directly with the cosine rule. Cos 55 is equals to 15 square plus AE squared minus 13 squared divided by 2 into 15 into AE. I'm gonna put it here. Okay, so if we bring it here, AE squared, 15 squared minus 15 squared minus 13 squared is 56, so plus 56 is equals to 30 AE times cos 55. So cos 55, and then if we bring it to this side, then 30 cos 55, that's our coefficient. AE plus 56 is equals to 0. Now I'm going to use the calculator to find the value of AE. 1 minus 30 cos 55, then 56, which is AE is equals to 12.85, or AE is equals to 4.36. Okay, now we can only accept one of these two values. Now this is AE. Okay, now in here this is greater than 90 degrees. Okay, that means if it is only 91, rest of the 89 will go here and here. Now if this is 55, then 89 minus 55 is 34. This could be maximum 34 if we take whole numbers, so this could be maximum 34 or 35. So that means this is the smallest angle. That means this will be the smallest size, sorry, smallest side. And since the angle is not close to 55, that means that this side will not be close to 13, which means AE is 4.36. We cannot take this. Okay, that means AE is equals to 4.36. Hope you understand that. Since we have AE, we could use sine rule. If let's find AE using sine rule. For that we need angle E. So if we want to find angle E, alternate way to find AE. Okay, instead of using cosine rule, we will use sine rule. So this is sine E over 15 is equals to sine 55 over 30. From here we will get E is equals to 70.93 or 109.06. Why is it calculator is giving me only this number? Where am I getting this one? So for that we have to go back to trigonometries. As we know, all the functions are positive here, and in this one sine is also positive. That means sine is positive here and positive here. Since the angle is an obtuse angle, that means the angle is right here. It's not in this one, it's in this one. Okay, so in this one we are getting in here sine E is equals to 0.945 and change. So since it's here, we have to go there and then come. Okay, we have to go and then come back. So that means E is equals to 180. We are going 180 in the positive direction, minus in the negative direction we are going sine inverse of 0.945. We are going this angle. Okay, if it was in the first quadrant, we would have gotten sine inverse of 0.945. Since it's in the second quadrant, it's this angle. Okay, we have the same triangle. This triangle is the image, is the reflection of that triangle. So that means this angle is basically this whole angle. Why whole? Because we count the angle from the positive side of x-axis. So this 109.606 is coming from there. So 180 minus sine inverse of 0.945 is 109.01. Previously it was 06 because I've used the exact value instead of using the rounded value, which is this. That's why we are a little bit off, but you don't have to worry about it if you're using the rounded value or exact value. If it's close to 109, you should be good. Now we have the angle E. Since we have angle E, we can easily find this angle. Since this is 109, then this is 180 minus 55 right here, and then 109 right here. So this angle is 180 minus 109 minus 55. 180 minus, I'm gonna use 109.06 to get more accurate value, which is 15.94. Okay, so if that is 15.94, which was angle ADE, angle ADE is equals to 15.94. I'm using 06 here, degrees. Now I can use sine rule again. Sine 15.94 degrees divided by the opposite side, which was AE. Opposite side of ADE is AE, and then the 13 and 55. I'm using 13 centimeter and 55 degrees is equals to sine 55 over 13. Why did I use 55 instead of 109? Because this is exact value. If I use 109.06, that's still, even though I'm using 2 decimal places, that's still rounded value. So for me, I usually like to use the values that was directly given in the question or that was not rounded. So yeah, but if you use the other one, you still get the same similar values. Then AE is equals to sine times 13 divided by sine 55, which is 4.36. We got the exact same value, 4.36. Okay, now we got AE. Now we can easily calculate this H. Okay, let me make another copy of this. Okay, height of triangle ADE is, let the height of triangle ADE be, say, H1. Okay, so therefore that means now we have AE here, we have the angle, so opposite, and then this is adjacent, sorry, this is hypotenuse. So we have to find opposite and adjacent. That means SOHCAHTOA opposite, that means not cosine, and hypotenuse, this one, not this one. So that means sine 55 is equals to opposite, which is the H1, and then hypotenuse, which is AE. So from here we can get H1 is equals to AE sine 55, and AE was 4.36 sine 55, 4.36 sine 55, we get 3.57 centimeter. That's H1. Now let the height of triangle ABE, I think, sorry, is it ABE? No, sorry, BCE. BCE. Triangle BCE BH2. Okay, let's change the color according to our diagram. So this right here is H2. So this is H2 and this is H1. So H2 is basically 10 minus H1. 10 minus 3.57. 10 minus 3.57 is 6.43 centimeters. Therefore, area of triangle BCE is equals to half into base into height. Base is 15 and the height is 6.43. So 48.225 centimeters squared. If your answer is close to 48.2 centimeters squared rounded to this value according to mark scheme, you should be good. Now we use the approach 1. We could use approach 2, which is finding either, since we already have one side, okay, we have to find this side and this angle, or this side and this angle. I'm gonna go with this side and this angle. Okay, so let me just make a copy of this page so I can reuse it down here. Sorry for making the solution too long. Okay, so this side is 15, that means this side is 10, this angle is 55. Okay, now we just have to find this side and this angle. Now first I'm gonna try to find this side. So in order to find this side, if we already have for triangle CDE, okay, for triangle CDE we already have two sides. We have to find another side. So that means if we have any angle, we can find the side CE. So there's no way we can find this angle or this angle right now with the information given, but we already found this equation in our previous we already calculated this angle in our previous method. So I'm gonna use that value directly from there, which was 15.94. so 15.94, if this is 15.94, then this angle is 9 minus 15.94, 74.06. So we can now apply cosine rule, which is cos 74.06 is equals to 13 squared plus 10 squared minus CE squared over 2 into 13 into 10. Okay, this will give us the value of CE. Give me a moment to calculate. So CE comes down to 14.06 centimeter. Okay, now we have calculated CE 14.06. Now we just need the angle. So for this angle, for this one, we could use cosine rule or sine rule. Okay, since we have one angle and all three sides, we could use both. I'm using sine rule to make it simple. So sine 74.06 over 14.06 is equals to sine C over 13. So from there we can get C. Give me a moment to calculate. 13 over 14.06 sine inverse of answer, which gives me 62.76 degrees. Okay, this angle right here is 62.76 degrees. That means this angle is 90 minus 62.76 degrees, which is 27.24 degrees. So area of triangle BCE is equals to half into BC into CE into sine of angle BC. Okay, now half into BC is 15, CE is, okay, let me calculate the angle here. Angle BCE is equals to 90 minus 62.76, 27.24 degrees. Now CE is 14.06, 14.06 times sine 27.24. Now half into 15 into 14.06 into sine 27.24. If we didn't make any calculation mistake, it should be close to 48.23 centimeters square. Yeah, it's very close to the answer we've got. It's a little bit off. The answer it's a little bit off from the previous answer because we rounded so many values in here. So first we rounded CE and then C and then BCE. So that's why it's a little bit off. But according to the marking scheme, as long as your answer is rounded to 48.2, then you should be good. So you can do either way. If you have any questions, feel free to comment down below.